Okay, in this presentation we are going to look at the Weibull distribution. So this is a worked example featuring the industrial applications. In this case it's the lifetime of electronic components. So a certain type of electronic component has a lifetime that follows a Weibull distribution with a shape parameter beta equal to 2 and a scale parameter eta equal to 1000 hours. Just notice that you can get varying types of notation for the parameters of the Weibull distribution. So here it's eta and beta, okay, which may not be consistent, but that's just the way life is. But one book is different to the other in terms of notation. Anyway, what is the probability that a component will fail before 500 hours? That's the cumulative distribution function we need. Determine the reliability function R of t, which gives the probability that a component will survive beyond time t. Now this is actually the complement of the cumulative distribution function, but we'll come to that shortly. Calculate the mean time to failure for this component. And finally, if a system consists of 10 such components connected in series, what is the reliability of the system at 1000 hours? And you may assume that the components are independent. So, first off, probability of failure before 500 hours. So that is a case of where we would use the cumulative distribution function of the Weibull distribution. So that is f of t equals 1 minus the exponential of minus t divided by eta to the power of beta. Okay, so f of t is the probability of failure before time t. T is the time, or t is greater than or equal to 0. That sort of mentioning that the sort of range of possible values for t when you're mentioning a probability density function or cumulative distribution function, it's important. You have to just mention it somewhere. So there, t is greater than or equal to 0. Always sort of put that stuff in. Eta is the scale parameter, okay, and beta is the shape parameter, okay. Now for this problem, beta equals 2 and eta equals 1000. So the probability of failure before 500 hours is f of 500, where that's the cumulative distribution function. That is equal to 1 minus the exponential of minus 500 divided by 1000, which is 1/2 squared. So we essentially have the exponential of minus 0.25, and that works out to be 0.2212. Okay, exercise B. The reliability function R of t is the probability of survival beyond time t. Okay, so that is the complement of the cumulative distribution function. Okay, R of t equals 1 minus f of t. So that is essentially the complement of f of t. That is the exponential of minus t divided by 8 to the power of beta. So in this case, for this problem, R of t is the exponential of minus t divided by 1000 to be squared, where t is greater than 0. And again, always put that stuff in for the 100% correct answer marks. Okay. Mean time to failure. The mean time to failure for a Weibull distribution is given by MTTF, which is essentially the mean. That is equal to eta times the gamma function of 1 plus 1 over beta. Okay, that is the gamma function symbol there. Okay. Now, what we have to do is do some revision on the gamma function. Okay, so this is if you're dealing with Weibull distributions and distributions like this, you probably will be using the gamma function and beta functions at some part of the exercise, and it's usually a given that you know these and you can use all these results without just by mentioning them. So anyway, the value of the gamma function at 1 over 2 is gamma of 1 over 2 equals the square root of pi. That's a special result of the gamma function, and usually you just get to sort of state it without having to make any proof of it. Okay, it's just a sort of well-known result that you will probably get to use without any further workings in these type of problems. Okay. Also, we have the recursive function. The gamma of x plus 1 equals x times the gamma of x. Okay. So just as a quick remark, the gamma function of 3 over 2, where 3 over 2 is 1 plus 1/2, that is equal to 1/2 times the gamma function of 1/2. So it should be roughly, it should be the square root of pi divided by 2. Bit of calculator work. So anyway, for beta equal to 2, there we have it there. Gamma of 1 plus 1 over beta is 1 plus 1 over 2. So we have the gamma function of 3 over 2, and that works out to be 0.8862. So the mean time to failure is 1000 times 0.8862, 886.2 hours. And finally, exercise D. For a series system, the overall reliability is the product of the individual component reliabilities. So if each component has the same reliability R of t, then the reliability of a 10 component system in series at 1000 hours is simply the independent events, essentially. Okay, it's the probability is independent events. Like that goes back to the introduction to probability type stuff. So the R of the system at 1000 hours is R of 1000 for the individual components to the power of 10. Okay, so it's 10 independent events multiplied by the probability of 10 independents multiplied by each other. So essentially, because they all have the same probability, it is to the power of 10. So we have the exponential of minus 1000 divided by 1000 to the power of 10. Now that simplifies greatly. So minus 1000 divided by 1000 is 1. Okay, but remember that minus is outside the bracket. Okay, so essentially we should end up with the exponential of minus 1 to the power of 10, which is 0.3678 to the power of 10, which is 0.00045. Okay, 4 decimal places there before we get to 4. Okay, so that's it, I think. Yeah, that's it. Okay, we'll leave it there.